Hello, chat. It's Chewy here. When I was doing the lab report, I'm still doing it. I've realized that we have to find the friction factor for the various pipe sizes to get our pressure drops, whatever, right? But then I realized you guys might not know enough Excel or spreadsheets to be familiar of how to find friction factors or use custom equations to find friction factors. Because as you know, the equation to find any friction factor relies on the Colebrook-White equation, where it is an implicit formula that relates the friction factor with the roughness, diameter, and the Reynolds number of your pipe, right? But what makes this equation not so easy to just plug it into Excel is the fact that it's implicit to friction factor. As you can see, F is mentioned on both sides, and you can't isolate it, right? It would be so easy if it was isolated, but this time the equation is implicit. So that means that you have to guess what friction factor for one side, apply all your variables, your epsilon, your diameter, your Reynolds number, the same friction factor that you guess on the left hand side, and pretty much pray that you guys get the same values on both sides, right? So there's a way to be able to make a function in Google Sheets or Excel to do exactly this process of guessing an f and iterating until both sides of the equation are relatively about the same. You can never get an exact solution, but you can get a very close solution that is just sufficient enough for your analysis, right? So here's a little spreadsheet that I made right here. I have the roughness, Reynolds number, and diameter, and it's very important for this one that you have the same SI base units, or you can temp with the functions themselves and be able to auto-detect whatever dimensions that you're giving the function, and to be able to convert it to however you want, okay? But here are my numbers. All I want to do is basically call function like Colebrook, right? And be able to reference my data like my roughness, my Reynolds number, my diameter, and hopefully I get a value such that I have a friction factor at the end of this box, right? As you can see, it's not an actual formula, so it's not even calculating anything, but we're going to change that by adding that function itself. So first, what you gotta do is go to extensions, go to AppScript. This is basically Google Sheets Visual Studio for any of its functions. A lot of people would put their customized functions in this hotbar right here, and you'll be able to use that function right away. Alright? But yeah, to be able to kind of describe the way that we solve for friction factor, you would have to put it in JavaScript format, right? But to save you guys the, the stress of finding it out, I have a copy and paste function script that I just Googled or just use chat to make for me, and of course check if it's actually right. But otherwise, I can just give you guys this in the description. Make sure that this is in Google Sheets, right? So your app script, put your function or paste your function into your script, and basically Control S or save your thing so that it is a registered function back into your Google Sheets, right? Now we can just use the same thing. I want to call function Colebrook, and then reference the same things in order: roughness in meters, Reynolds number, and a diameter. And this time, instead of just being stuck on loading, you will actually get a number after a few seconds. So that is pretty much the answer that I got here. And of course, you can drag it. You can drag your calculation across all of your numbers, and you'll pretty much get the same. You'll pretty much solve for each and every one of your conditions, right? But if you want to test out your accuracy for your friction factor, you can just put it on Excel and basically copy and paste this formula into that and put in your parameters. And if I want to test like this value per se, the first row, I would just put it into my Desmos and see that both of the values are the same, with just an exception of maybe this place number, but it's within tolerance. So I wouldn't use anything passing like, oh no, like these numbers, but it's up to you, right? So Anyway, that's how you find a friction factor and make a function into Google Sheets so that you can find your friction factor using the Colebrook-White equation for iteration. Okay, but if you are also using Excel, there's also a way to do that. So I'll get to that right away. All right. So here's my Excel version of what I basically created in my Google Sheets in the first place. Same numbers and everything, so we can cross-compare all the friction factors. But it's pretty much the same tactic for Excel. You want to have a Visual Studio like app scripts for Excel and be able to import a function there, save it so that you can just reference the function right away. Okay. But Excel doesn't have a designated extension bar. It's something that you have to add yourself. So what you can do is go to search and search add-ins and check in Analyst Toolbox VBA. Another way to get to the add-ins part is go to Options or go to File, go to Options, scroll down to find add-ins, and go to Go here for Manage Excel add-ins, and just check the VBA part. Okay, VBA is the Visual Basics for Applications, basically our Visual Studios. Okay, when you add it, nothing's gonna happen until you enable the developer part of your Excel, which means, and how you get to that is you just right click anywhere on your little ribbon right here, like this blank space here, go to Customize Ribbon, and you check the developer part in the Customize Ribbon section. When you do that and select OK, a new, I guess, tab appears. It's called Developer. You just click that, go to Visual Basics, and you basically enter kind of like the folder of all your, I guess, functions on here. Now to get to the same page as app scripts with all like the blank sheet of paper, the blank script so that you can actually put your function in, you just gotta right click Microsoft Excel objects, go to insert, go to module, and look, the module pops up an open window for your script, and you can copy and paste your function for Colebrook here. Like last time, or like Google Sheets, I will provide you guys the I guess the function for this, and I formatted it in the same ways as I did it in Google Sheets. I would reference the epsilon first, the Reynolds number, and diameter. It takes all of those variables and parameters. It guesses the same friction factor, 0.02 for this case, and the same tolerance, and we'll iterate until how many you guys want, right? And this is the iterative function or a loop to do that, and it will return me, and if the values are about the same in the Colebrook-White equation, it will return me that number as my friction factor. Pretty easy, right? So how you save this one is Alt-Q, right? So Alt-Q, and that pretty much just exits it out, and you also save it too. So let's test it out. Colebrook, and as you can see in Excel's like pop-up thing, you might be able to see your function that you just made pop up right here. So I just tab that, Colebrook, and I just reference this, that, and that in that order, and I'm able to just generate a friction factor approximation, right? I'm just gonna make this a little neater, but I want to see if it actually matches up with my Google Sheets, and as you can see, they're around the same. Yeah, they're about the same. This is just more digits to it, but as you can see, all of the numbers are pretty much the same. So you can reliably use this method as you want, okay? And of course, if you guys want to edit your function on either platforms, you just need to repeat the accessing steps and be able to just type in whatever you want, okay? But otherwise, this is a pretty good tutorial of how to find friction factor for your last project. You can do it in multiple forms, either through Google Sheets or your Excel. Either way works. It's a little bit easier to do it in Google Sheets because it's a little bit more user-friendly for you guys, and you can just access the extension bar right away. But hey, there's an option for Excel too if you guys like. Otherwise, that's pretty much it for this video. If I talk a little bit too fast, don't worry, just slow down, and I'll make sure to copy and paste these functions in my description. Okay, so I'll see you guys later, and I'm out.